Hi everyone, let's take up a question from ray optics. An observer can see through a small hole on the side of a jar, radius 15 cm, a point at a height of 15 cm from the bottom. The hole is at a height of 45 cm. When the jar is filled with a liquid up to a height of 30 cm, the same observer can see the edge at the bottom of the jar. If the refractive index of the liquid is n upon 100, find out the value of n. Let's try to understand it. There is a hole in the jar at a height of 45 cm from the bottom. An observer through this hole can see a point P inside the jar, which is located at a height of 15 cm from the bottom. Now this jar is filled up with a liquid up to a height of 30 cm. And now the same observer is able to see the edge at the bottom of the jar at point P, which is at a height of 15 cm from the bottom. Let us try to understand it. A ray starts from the edge of the bottom, and this gets reflected at the air-water interface, and the ray bends away from the normal. So now this same observer is able to see the edge at the bottom at point P. Let us apply Snell's law. N sin I equal to 1 sin R. This is our angle of incident and this is angle of refraction. Since radius of jar is 15 cm and the height of this hole is 45 cm from the bottom and water is filled up to a height of 30 cm. So length of this is 15 cm and this is also 15 cm. So this angle is 45 degree. So angle of refraction is also 45 degree. Sin I can be find out since we already have these lengths. This is radius of jar 15 cm and height of liquid is 30 cm. So let us put the values. Sin I is 15 upon root of 15 square plus 30 square, and this is sin 45 degree. Let us solve it. This is equal to 1 upon root 2. This gives us therefore refractive index n is equal to root of 5 upon 2 and this is approximately equal to 1.58. So this can be written as 158 upon 100. Therefore n is equal to 158. Alright, thank you very much.